Good morning. Today we're switching gears a little bit. We're looking at solving polynomial equations that are in factored form. So we've been adding, subtracting, and multiplying polynomials. Now we're going to look at a full equation in factored form, meaning instead of a big long equation like 2x squared plus 4x minus 8, we might look at something like x plus 5 and x minus 3. This is what we call factored form. Alright? Now, don't be scared that there's graphs here. I'm just going to use those to make a point. We're not actually graphing today. So it says a zero product property. Let a and b be real numbers. If a times b is 0, then either a has to be 0 or b has to be 0. So, for example, if factored form looks like this, and this was equal to 0, well, either this part, a, or this part, b, would have to be equal to 0. And it could be any letters. It could be x, y equals 0. Well, either x has to be 0 or y has to be 0 in order for that to be true. So we could have two potential answers that are equal to 0. So it says the zero product property is used to solve an equation when one side is 0 and the other side is a product, meaning multiplied, of polynomial factors, like this up here. The solutions of such an equation are called roots, also known as the zeros of the function. So this is my y-axis, and here we have 1, 2, the 0, -1, -2. So if I'm looking at this point right here and this point right here, these are what we call our zeros of our function, because it's when y is at 0. It's crossing the x-axis. So it's when y has reached 0, right in the middle here. So these are our two solutions that we would be looking for when we solve a polynomial. Same thing here. This is a 0 of a function, and this is a 0 of a function. This is also called a solution. It's because it's when y has reached 0, the x-axis, really. So, reminder that both of these, well, maybe not a reminder, this might be new information. This graph right here is called a, I was going to say polynomial. That's wrong. It's called a parabola. And this is something that we'll get to graphing a little bit later as well. But parabolas form that nice curve, like an arc. Alright? So that's a little bit of intro information. Now let's actually solve an equation. So we're going to figure out what are the 2 points where our graph is going to cross, our parabola is going to cross the x-axis. So either this part or this part has to be equal to 0. We could have two answers. Either one could be equal to 0. So we're going to set this part here in parentheses equal to 0, because 0 times this would still make it 0. Or the other side here, this could be equal to 0. X plus 2 could be equal to 0. So all we have to do is solve both sides to find our zeros of a function. So if I add 4 on both sides, I get x equals 4. And here, if I subtract 2 on both sides, I get x equals -2. So these are my zeros of a function. What this means is if I were to graph this, my graph would cross at -2 and at 4. So this parabola might look something like that. You don't need to graph it. I'm just showing you what it might look like. So let's try our next one. Either one of these two pieces has to be equal to 0 in order for this to be true. This is like a times b equals 0. Either a, this whole piece, or b, this whole piece, has to be equal to 0. So let's set them both equal to 0 and solve. So solving this one, I'm going to add 3. Some of you might be able to do some of this in your head, and that's okay. So one answer, m, is 3. And the other, I need to subtract 12. And I get 4m equals -12. And then divide by 4. M would give me a -3. So if I were to graph this one would cross our x-axis here when y is 0, remember, we don't really need these lines, but at -3 and at +3. So our graph or parabola would look something like that. Alright, let's try one more. Either one of these could be equal to 0, so let's set them both equal to 0. 3x plus 1 equals 0, and x plus 6 equals 0. So when I solve this first one, subtract 1. So I get 3x equal to -1. And then get rid of that 3, divide by 3. We have x equal to 1 divided by 3 is not 1, it's not 3, it's literally just 1/3 still. That's okay. Doesn't always have to be a whole number. Same thing here, subtract 6. So x equals a -6. So again, if I were to graph this one, they're both negatives, that's okay. We would cross at -6, 1, 2, 3, 4, 5, 6, and at -1/3. So our graph, ooh, that was a bad parabola. It's hard to draw on this thing. Might look something like that. Should be even though. Nice curve there. That's a little better. Alright, now we're going to learn a new skill that we can apply to the skill we just practiced. So in the past, let me just bring up a blank slide for a second. We took two numbers. For example, if I wanted to multiply 4x by 3x plus 12, I would draw a box and I would multiply 4x times 3x plus 12, just like that. Same thing if I wanted to multiply like 2y times 3y squared plus 1y minus 5. Oops, parentheses. I would draw a box, three terms by one term, and I would multiply all of this out. So what I'm really, what I'm really going to be doing now is taking my terms, this is like a already multiplied two terms here, and I'm going to factor something out, or take out what they have in common. It says the greatest common monomial factor. Mono means, remember, one term or one factor. So what do these both have in common that I could pull out? Think of literally taking something away from both of these. Well, they both have a 4. They're both multiples of 4. I could take that out. And they both have at least one x. So I could take out a 4 and an x. So here, now I'm going to look what's left if I took out a 4 and an x. Well, there's no numbers left, so it would really be a 1 because 4 times 1 is still 4. If there's one x gone, you would have needed to put one other x in order for there to be two x's. Think of your smoothie. If you take one apple out, you still got one other apple in order to get two. So x times x would give you x squared. Then over here, of this second box, or second smoothie, if you want to call it that, 4 times what will give us -4? I pulled out a 4. Well, it has to be a negative, so a -1. 4 times 1 would give us -4. And we pulled out an x, so there's no x's left. So this is our answer. I pulled out a 4x, and I'm left with 1x minus 1. Let's try another one. Here are my two terms. Remember, the sign goes with the number after it, this -1 with the 4. What do these both have in common? Well, 6 and 9, they're not the same number, but they're both multiples of 3. Because 2 times 3 is 6, and 3 times 3 is 9. So this is the only one that has an x, so I can't pull an x out of both, but I can pull a y out of both of them. This one has 2, this one has 1, so I can pull out a 3y. That's my monomial factor, monomial term that I can pull out. So what's left over that I need to pull out, or that's left if I take out a 3 and a y? Well, think 3 times 2 would give me 6. There's 3 x's that still have to be put in somewhere. They got to come from this group up on top. That would give me the x to the third. And if I took out the y, there's no other y's I need to put in. Think these two multiplied would give me this term. Then 3 times 3 gives us 9. I took out one y, but I need 2 total, so I need 1 more there. And that is what's left over on top. So my terms, I have 3y, and that's what I pulled out, and I have left 2x to the third plus 3y. So we're just moving backwards from what we learned the other day. So here's the same thing, but 3 terms. I'm going to draw my box between each term. What do 3p to the 4th, 15p squared, and 6p all have in common? Well, I can see right away they all have at least one p, so I can take out a p. They all have at least one p. If they each had at least 2 p's, I could take out 2, but I only have 1. And these are all multiples of 3. If you wanted to take out the negative, you can. You don't have to. Sometimes your answer key will take out or factor out the negative and leave the first term positive. Either way, you'll get the same answer. So if I take out a 3p, well, 3 times negative 1 will give me negative 3. I took out 1p here, but I need 3 more to get to 4, so I need a p to the 3rd. Then over here, 3 times 5 would give me 15. But p, I need a p to the power of 2. I need 1 more to give me 2 p's. And then last, 3 times 2 would give me 6. And there's already a p there, so we're good. So our answer is 3p times negative 1p to the 3rd plus 5p plus 2. Alright, last one. I would like you to try this one on your own, and then click play to see if you got it right. So 35 and 5, they're both multiples of 5. And they both have at least one a and at least one b. So I know 5 times 7 gives me 35. There's one a, but I need 2. There's one b, but I need 2, so I'm going to write one more. And then 5 times negative 1 would give me negative 5. There's already an a and there's already a b. So my answer is 5ab times 7ab minus 1. If you're not sure if you got it right, multiply these two to see if you get this middle term here, and then multiply the first and the last there to see if you get that term. It should work out. So now, we're going to factor it out. It's just equal to 0. So just like we did before, we're going to factor out what these two have in common, and then whatever we get, we're going to set both parts equal to 0. So we're kind of combining our two skills together now. So 15 and 50 both are multiples of 5, and they both at least have a y. So 5y, what multiplied by 5 gives me 15? Well, 5 times 3 is 15, and there's already a y there, so that one's good. 5 times a negative 10 will give me negative 50. I have one y, but I need 2, so I have one more there. So now I have 5y, and then 3 minus 10y, but it's equal to 0. So just like we did, oops, too far, right here, if we have two terms equal to 0, we got to set them both equal to 0 to figure out where my polynomial would cross the x-axis. So this really, you could put it in parentheses, you don't need to. So we would have 5y equal to 0, and 3 minus 10y equal to 0, and we need to solve both. So the opposite of multiplying by 5 is dividing by 5. So we would have y equals 0 divided by 5, which is 0. Or on this side, if I solve here, get rid of just your number first. This one looks tricky, but this is really multiplied, so you can't get rid of the negative 10. You got to get rid of that negative 3. Subtract 3. Get rid of the positive 3, sorry. So I have negative 10y equal to a negative 3. And then divide by negative 10, because it's multiplied there. This was multiplication, so we divided. I know two negatives multiply and divide to make a positive, so I'm left with 3/10. Or if you wanted to put it as a decimal, that would be 0.3. So you don't need to go this far, but if you wanted to know, this would cross the x-axis at 0 and at 3/10. So your parabola might look something like that. You don't need to do that last part, you just need to solve, meaning find out what two numbers is y equal to. So now this next one looks a little tricky because it's not equal to 0 like we've been given. But how could I make this equal to 0? Well, if I just move this over to the other side, then I have 0 or nothing left on one side, and that's fine. So to move this to the other side, I'm going to add 25r. The opposite of subtracting it would be adding 25r. So now it's equal to nothing, 0. But you can't combine these because this is r squared, and this is just r. So write them separately. Negative 30r to the power of 2 plus 25r. Now it looks like the last one, so I'm going to factor out what they have in common. So I'm going to draw my box around it. Both of these are multiples of 5, so I'm going to pull out a 5. If you want to pull out a negative, you can. And they also at least have an r. Now I don't have any room on top, so I'm just going to write this down below. 5 times 6 gives me 30, but I need to be a negative. And I need one more r. And then 5 times 5 is 25, and there's already an r there. So my answer here, I have 5r and then 6r plus 5, all equal to 0. So it said solve, which means it's equal to 0. We need two answers. So 5r could be equal to 0, or 6r plus 5 could be equal to 0 in order for this to be true, in order for one of them to equal 0. So 5r equals 0 and 6r plus 5. You got to solve both. So if I divide by 5, this is the easy one because 0 divided by 5 is still 0. And then on this side, subtract 5. And then the opposite of multiply by 6 is divide by 6. So I have a negative. 5 divided by 6 is still 5 divided by 6. If you want to write it as a decimal, you can. Otherwise, those two answers will work. Those are the two places where my parabola, my graph, my curve, will cross the x-axis. Alright, let's try a more application type problem. It says, a table display in your school library sits on top of two rectangular tables arranged in an L shape, as shown right here. The tabletops have the same area, so this table is exactly the same or equal to this table. So part A says, write an equation that relates the areas of the tabletops. Okay, so areas. Area of a rectangle is base times height. I know that. So let's write out an equation that relates the areas. Well, up here they said that they were equal. They have the same area. So one has to be equal to the other. So let's find the area of this top one first. Base times height. Well, the base is 2 right here, and here it's w. So it's not 2 times w, it's just next to each other, 2 and w, or 2 plus w. That's our base. But that whole thing is multiplied by our height, which is w. So that's the area of the first part. Then the second table, base is right here, w, times our height. Ooh, we don't know what the height is. I know the base is w, and the height is, I know this whole thing is 10. I just want this piece right here. If this part is w over here, this side must also just be w for this chunk. So the whole thing is 10, and I only want this part. Couldn't I take away this w piece right here? So can I do 10 take away w? Would leave me with this chunk, right? So that's the length of the other side. So that's our equation. Now it says find w, find the value of w. So what we're going to do is we're going to distribute, because that's what we know how to do. We know how to multiply these. W times 2 is 2w. W times w is w squared. If you want to use your boxes to multiply w and then 2 plus w, you can, and you'll still get the same thing. Same thing here. W times 10 is 10w. Don't put w 10, always put your numbers first. And then minus w times w is w squared. Now, if we're trying to find the value of w, we're going to try to get it equal to 0 because we know how to factor then from that point. So I'm going to move whatever's on this side over to the other side. So I'm going to add w squared, or add 1w squared. This is also a 1. So I have 2w, 1w squared plus another 1w squared is 2w squared. It's like 1 orange plus another orange is 2 oranges. The exponents don't change. And then those are gone, so we have equal to 10w. So we need all of the letters and numbers on the same side, so I'm going to subtract 10w over to the other side. Notice I'm putting the terms under the like terms. Notice I put this under w's because we can combine those. Notice I put this under w squared because you can combine those. So those eliminate and we're equal to 0. And 2 minus 10 is negative 8w, and then plus 2w squared. If you want to write the bigger term first, you can, but since this is how it's written, I'm just going to leave it for now. Now, I need to find what w is. Well, I know I can factor out what these have in common now. I know this seems like a lot of steps, but that's what we've been practicing, factoring out what they have in common. These are both multiples of 2, and they both have a w. So what's left over? 2 times negative 4 would give me negative 8. There's already a w there. 2 times 1 would just give me 2, and there's already a w, so I need one more, w squared. So I have this piece, negative 4 plus 1w, and I have a 2w, all equal to 0. I just wrote out both pieces here, equal to 0. So now, well, 2w here could be equal to 0, or negative 4 plus 1w could be equal to 0. If I divide by 2, w equals 0. And if I solve this one, get rid of your addition and subtraction first, I'm going to add 4. 1w equals 4. If I divide by 1, it doesn't change my answer. W is still 4. So here are my two answers. But think in real life, you guys. If we're talking about w as the width of our table here, can you have a width, or how wide your table is, and can that be 0? Can you have a width right here of 0? That's not possible. So we need to think realistically. The only answer that would make sense is 4. So the value of w, well, w equals 4. Then part C says, what's the combined area of the tabletops? Well, if w is really a 4, well, this whole length is 6. 6 times 4 is 24. That would give us this area. And they told us they were the same, so you don't really need to calculate this one. 24 plus 24 will give us 48. You could put your units on there, feet squared. This one would be feet. And those are my answers. Now we have one last type of skill to learn here. It's not anything that you need to memorize. It will always be given to you. It says we have a vertical motion. A projectile, which is really any object that is propelled into the air, but has no power to keep itself in the air. So like a baseball, you throw it in the air, it's got to come down. You throw anything into the air, a crumpled ball of paper into the air, it's got to come down. A frog jumps, it's got to come down. Okay. A plane, however, has the ability to keep itself up in the air. That has power. So it's not an object that's just going to go up and down. A plane would go up, stay there for a long time, and then go down. So plane is an exception to this rule. The height of the projectile can be described by a vertical motion model. So if I told you I threw a ball into the air, and I wanted you to calculate what's the height way up here, what's the highest point it gets, we have an equation that can help us figure that out. And this is what that equation looks like. You do not need to memorize it, you just need to know how to use it. So it says the height in feet of a projectile can be modeled by this equation. It says t is the time in seconds, so t right there would be time that the object is in the air. V is the vertical velocity, normally just referred to as the velocity, and s is the initial height. I like to say starting height because it's the letter s. So h is the ending height, where it ends up at, which is usually 0. You normally start and end at the ground. Okay? So, like it says here, initial height is 0 unless otherwise indicated. If they tell you you're standing on a deck that's 20 feet high, well, you start at the deck here, which is 20 feet high. Okay? So let's take a look at an equation. This one already happens to be factored for us. So instead of factoring out like we did back here, figuring out our two pieces, they already factored for us and gave us an equation. It says the diver jumps from a diving board that is 24 feet above the water. The height of the diver is given by this equation. They already factored in the 24, and that will land on the water. They gave us the equation already. It says the height is measured in feet, and the time is measured in seconds. When will the diver hit the water? It says, can you see a quick way to find the answer? Well, we know the height at the end, it better end on the ground or at the surface of the water, which is 0. So, what's a quick way to find the answer? Figure out what is t. Well, didn't we learn earlier that if something's equal to 0, one of the parts has to be equal to 0 in order for this statement to be true? So let's set all three parts equal to 0. 0 equals negative 16, 0 equals t minus 1.5, and 0 equals t plus 1. These are all equations that we need to solve. Figure out which one's going to make the most sense. Well, does 0 equal 16? Not possible, you guys. You can't even solve that one. If I solve this one, I would add 1.5. So I have 1.5. There's one answer that might make sense. And over here, if I subtract 1, I have t equal to a negative 1. So we have two answers that might make sense. It says t is measured in seconds. So this is t is our time. Can we have a time that's negative? Can you have negative time? That doesn't make any sense. So all we had to do, you guys, is set all three parts equal to 0 to figure out what is the time it'll take for the diver to jump off and land in the water. And that time would be 1.5 seconds. Because none of our other answers made sense in order for this to be true. So here's our last one. Here's the equation already given to us. We need to plug in the information on this one. So it says, a startled armadillo, here's an armadillo, jumps straight into the air with an initial vertical velocity, so here's our velocity, of 14 feet per second. Vertical velocity, that's our v that we're going to plug in there. After how many seconds does it land on the ground? So we're trying to figure out t. You're never, ever, ever going to plug something in for t. T will always be t. That's what you're going to try and figure out. So s is our initial starting height. If they don't tell you, you can assume it's on the ground, which is a height of 0. You can also assume that if you're jumping off the ground, you're also going to land back on the ground. So our height at the end is also going to be equal to 0. So I'm just going to copy this down, negative 16t squared plus v. We know what v is. Our velocity was 14t. T is our time. We'll try to figure that out. And then plus s, our starting height was 0. You don't really need to add 0. It's not going to do anything to your equation. So this is my equation. Now, we can factor out what these two have in common. These are both multiples of 2, and they both have a t. So if I factor out a 2, I'm left with a negative 8, and I have a t left over here. If I factor out a 2 here, I have a 7 left over, and the t's already been taken care of. So I have 0 equal to negative 8t plus 7, and then times 2t. You can put parentheses around this too if you want. You don't have to. So they want to know how many seconds does it take to land back on the ground? Well, let's solve both. We could have negative 8t plus 7 equal to 0, or we could have 2t equal to 0. So if I solve this one first, get rid of your addition and subtraction, I'm going to subtract 7. And then divide by -8. Eliminates, and I get t equal to, well, two negatives make a positive. We have 7/8 on this side. It's a positive number, that's good. Positive time, you can't have negative time, remember. And if I divide by 2 on this side, 0 divided by 2 is still 0. You can't have a time of 0. You can't jump off the ground and land back on the ground in a time of 0 seconds. It doesn't work. But 7/8 of a second, it's a quick jumper, but it could happen. It's some sort of elapsed time. So our answer, after how many seconds does the armadillo land on the ground, would be 7/8 of a second. I know we went through this information fairly quick, but if you have any questions, please let me know. On your homework, you have to do 1 through 21 odd, which is most of the front side. Then the rest you have to do the entire thing. Number 36 is similar to one that we already did, but is not the same. Alright? This one we did do, but you have to copy it down and show your work. Alright? One thing I would suggest using from your notes was your vertical motion model. It's not given to you on this equation, but it is right here. H equals -16t squared plus vt plus s. You need to plug in v, s, and h. Good luck!